Welcome to our live stream on differential calculus. In this video, we are going to see how we can use the rules of differentiation, the chain rule and the power rule of differentiation to find the stationary points of the given functions. So we begin with the very first one. So applying the chain rule, we can let u to be equal to x minus 1, then du dx will be equal to 1. Then we'll get y to be equal to u cube, and dy du will be equal to 3u squared. So we can now find dy dx, and that will be equal to du dx times dy du, and that will be equal to du dx is 1 times 3u squared. So we substitute u back. U is x minus 1, so that gives us dy dx to be equal to 1 times 3, which is 3. U is x minus 1 all squared. So that is dy dx for us, 3 into bracket x minus 1 squared. So we now equate dy dx to 0, because at the stationary point dy dx is equal to 0. So let dy dx equal 0. This implies that 3 into bracket x minus 1 squared is equal to 0. So this will give us equal to 0 over 3, which is 0. So we have x minus 1 equals square root of 0, which is also 0. Plus or minus square root of 0 is 0. Then this will give us x to be equal to 1. Now that we found x to be 1, we can find the value of y. We substitute the value of x, and that gives us y to be equal to 1 minus 1 cube. So y will be equal to 0 cube, which is 0. The stationary point to be 1, 0. If you want to go further, we can see that these stationary points will be a point of inflection. In our next video, we will see how to determine whether a turning point is a point of inflection, and the concavity, the type of concavity of the turning point. For now, let's look at the of our question. So we find dy dx. Dy dx will be equal to x cubed. So when we differentiate x cubed using the power rule, we get 3x squared minus 10x. So at the stationary point, dy dx equals 0. So let dy dx equals 0. This implies that 3x squared minus 10x is equal to 0. So when we factor x, we will obtain 3x minus 10 is equal to 0. We have either x equals 0 or 3x minus 10 equals 0. Dividing through by 3 for the second factor, we get x to be equal to, so 3x will be equal to 10. Dividing through by 3, we obtain x to be equal to 10 over 3. So now we determine the corresponding y values. So when x equals 0, y will be equal to 0 cubed minus 5 times 0 squared plus 1. And that will give us y to be equal to 0 minus 0 plus 1, which is 1. So we have a turning point here, or the stationary point to be 0, 1. Then when x equals 10 over 3, y will be equal to 10 over 3 cubed minus 5 times 10 over 3 squared plus 1. So this will give us, we cube the 10 and the 3 to get 1000 over 27 minus 5. 10 squared is 100 times 5, that will be 500 over 3 squared is 9 plus 27, plus 1. The LCM will be 27. So we have 1000, 9 into 27, 3 times 500. That will be 1500 plus 27. So that will give us negative 500 plus 27, which is negative 473 over 27. So the second stationary point will be 10 over 3 and negative 473 over 27. So we found the stationary point. The other one was 0, 1. Then the second one was 10 over 3, negative 473 over 27. In our next video, like I said, we will see how to determine whether the stationary point is a maximum or minimum point. Now to our final question here. We have y equal negative 7x plus 1. When we differentiate using the power rule, we obtain negative 7 plus 0. So when we let the y dx to be equal to 0, we obtain negative 7 equals 0, which is not possible. Therefore, the C has no stationary point. That's no stationary point. So we've answered the question. We found the stationary point of these to be 1, 0. Then for this, we had 0, 1, and 10 over 3, negative 473 over 3 over 27. Then over here, the stationary point, there's none. So in the next video, we will look at concavity and point of inflection. Please Remember to subscribe to this channel. Thank you so much. Welcome to our live stream on differential calculus. In this video, we are going to